Thanks for joining me today. We're going to talk about how to build modern cloud-native applications with Kubernetes and open source databases on Azure. My name is Sunitha Muthukrishna. I'm a Senior Program Manager at Microsoft. I work on Azure Database for Postgres, SQL, MySQL, and MariaDB. In my previous roles, I've worked on Azure App Services, built PHP applications and Python applications. If you have any questions, you can always feel free to reach out on Twitter. My Twitter handle is mksunny. In today's agenda, we'll be walking through what's new with open source databases on Azure. We will walk through an introduction on Azure Kubernetes services, what are some of its top scenarios and what are its best practices. Quite a few demos today. I'll walk through how to deploy a cloud-native WordPress application, do a simple Postgres deployment, showing you GitHub actions to deploy data into a Postgres server, how you can scale and manage your demos with how you can diagnose and solve issues. Cloud-native applications include a lot of complex moving parts, which are typically worked with few or many development teams. Now, one such part is typically a database that's involved in your application. Some of the characteristics of cloud-native applications are scalability, supporting microservices architecture, continuous integration and deployment. Some of these capabilities are available as part of Azure MySQL and PostgreSQL. The first one is global reach. Azure MySQL and PostgreSQL are available across 50 plus regions. You can take advantage of native integration with other Azure services within the Azure ecosystem. It is easy to achieve the enterprise grade capabilities that help you have an efficient and productive app development as well as achieving operational excellence. Both PostgreSQL and MySQL services give you an SLA of 99.99% uptime. By being built on the Azure architecture, it has inherent high availability, redundancy, and resiliency capabilities to mitigate any database downtimes, whether it is due to planned or unplanned outages, without needing any additional configuration on your part. You can easily scale up when you're using these database services. The elastic provisioning of capacity without the need to manage your infrastructure, and you also have the ability to do event-driven autoscaling. You can scale with confidence when you're using either one of these services, whether it's MySQL or PostgreSQL. You can scale them up and down based on your application needs. The Azure portal makes it pretty easy for you to scale up either your compute or scale up your storage. With compliance, you can take advantage of more than 90 compliance certifications, whether they are specific to a region or specific to an industry. Last but not the least, security. Both services provide advanced security features and capabilities, whether it's using Active Directory integration or whether it's using KeyWall. You can get advanced threat protection and various other features and capabilities available as part of these services. Let's take a quick look back and see what deployment options are available for PostgreSQL and MySQL today. You have single server, which is available for both PostgreSQL and MySQL. This is enterprise-ready, fully managed, community, open source engines for both MySQL and PostgreSQL. So you get all the same capabilities that you would see with the community version, but in a fully managed database as a service. Now, this can handle mission-critical workloads with predictable performance. It also gives you dynamic scalability. We also offer Hyperscale Citus. Hyperscale Citus is a deployment option that horizontally scale queries across multiple machines using sharding. It's a query engine that helps you get faster responses on larger datasets. It's generally used for workloads with large datasets, typically exceeding 100 gigs of data. We support many features that are tailored for security, performance, and manageability. As I previously mentioned, we do support 50 regions in Azure. Here are some of the companies that use our services like T-Mobile and HSBC. Looking at some of the features and capabilities that you get within these three buckets of security, manageability, and performance are using Active Directory authentication or customer managed key encryption. You also get read replicas, you get intelligent performance, you get reserved instances for all our GA services, you get storage autogrow. All these capabilities help you have a resilient, performant, scalable database for your application as your application grows. I'm glad to announce our new deployment option called a Flexible Server. And we also have the Azure Arc-enabled Postgres HyperSQL. Flexible Server is also a fully managed database service but it's designed to give you more control with a simplified developer experience. In general, the service provides you more flexibility in terms of server configurations and user requirements. Currently, Flexible Server is in public preview. Now let's talk about Azure Arc. Azure Arc enabled Postgres Hyperscale is one of the database services as part of the Azure Arc enabled data services. Azure Arc makes it possible for you to build hybrid solutions in an environment of your choice. Azure Arc gives you elastic scale, it gives you self-service provisioning, it gives you unified management, it also gives you a disconnected scenario support, which you might need based on the type of applications that you're running. Today we're going to be talking more about Flexible Server, and the demos will be focused on our Flexible Server. Let's kind of do a deep dive on Flexible Server. The first thing that you get with Flexible Server is having more control on your databases. Some of the capabilities that we offer is network isolation with virtual network integration, capabilities to secure your data. More server parameters are available to you, will allow you to tune and optimize your server based on your application's needs. You can also control the maintenance window of when your database server gets updated for planned upgrades and patches. The most critical part here is also building resilient apps with high availability. With Flexible Server, you get multiple zone redundancy. Multiple availability zones give you the ability of getting high availability by the redundancy provided to you as part of this feature. You get fast failover with practically no data loss. This also helps you enable co-location of your application and database in the same zone, which helps and boosts the performance of your application. Last but not the least, you also get a simplified developer experience. If you have used Azure CLI before or any other kind of command line interface tool, the CLI experience when using Flexible Server makes it very easy. Learn how to provision, how to tune your server, how to manage your server using very simple commands. As you develop your application, sometimes you may not want the server to be running at all times. In such scenarios, we have a feature called a start and stop, which allows you to optimize your cost. We also have much lower tiers through our burstable servers, which gives you the flexibility to try out the service without breaking the bank. You might wonder what's actually different between single server and flexible server, since they both are fully managed database services with enterprise-grade features. The difference between the two are primarily the high availability. In single server, you get a single availability zone. There's not much of control with that. In Flexible Server, you get multi-availability zones, which gives you the redundancy needed for high availability, which also comes with the co-location, as I mentioned before. In terms of the maintenance, the scheduled maintenance is only available in Flexible Server, which allows you to customize when your servers get upgraded and patched. With the start and stop feature, you can optimize your costs. Even though my slide isn't updated here, but start and stop feature just went live for single server as well. So you can now optimize your cost on both single server as well as Flexible Server. Some of the other features like customer managed keys and for encryption, reserved instances, cross-regional replicas are all planned, but currently not available in the preview version of Flexible Server. Now let's take a look at the Azure Kubernetes services. Kubernetes is the leading platform that provides the ability to provide reliable scheduling of fault-tolerant applications. Now, AKS, or running Kubernetes on Azure, is a managed Kubernetes offering, which basically simplifies the container-based application deployment and management. Now, Kubernetes on its own is not enough. You need the agility of applications that are containerized with the help of the provisioning being automated, the patching being done for you, and all those capabilities that you typically tend to get with a managed service. Having the capabilities of a managed service plus giving you enough control to build and run and deploy your Kubernetes applications. You also need an enterprise-grade feature set. Azure Kubernetes Service makes this possible. Deploying a managed Kubernetes cluster in Azure is very simple. It just takes a couple of simple commands and you're up and running, or you can use our portal experience to quickly get started. Azure handles all the critical tasks like the health monitoring and maintenance of the Kubernetes masters. You only have to manage and maintain the agent nodes, and you only pay for the agent nodes within your clusters and not for the masters. Now let's look a little bit deeper into Azure Kubernetes Service. What kind of features do you get with Azure Kubernetes Services? You get proactive, actionable recommendations as best practices from Azure Advisor based on your configuration usage telemetry for your resources. You can improve performance, availability, guarantee security of your cluster even before there's a problem by following some of these recommendations. You can resolve common issues with intelligent self-diagnostic experiences available to you in the portal. You also get multi-layer security. You can easily enforce compliance rules using Azure Policy. You can apply access control using Azure Active Directory or role-based access. You can encrypt the disks using customer managed keys. You can store them in Azure Key Vault. It also supports Kubernetes API server as a private endpoint using Azure Private Link, and you can get threat detection recommendations through Azure Security Integration. All these layers of security help you make sure to stay on top of any kind of security issues. You get enterprise support through our Azure support experience, through certified Kubernetes experts, through our interactive portal experience for support. You get faster diagnostics and troubleshooting as part of the inbuilt experience for Kubernetes services. With unified management experience, you can actually get a central inventory and monitor all the assets running anywhere on-premise to edge. You can also consistently apply policies, role-based access controls, governance. You can deploy Kubernetes using GitOps-based workflows. If you're using different Kubernetes-supported community solutions, could be Helm charts, you can leverage all of those same tools to build Kubernetes applications on Azure through AKS. Here are some of the top scenarios for using Kubernetes on Azure with open source databases. The first is lift and shift. It makes it easy to lift and shift any of your Kubernetes applications running on other platforms onto Azure easily. It also gives you the cost optimization that you need by reducing the development overhead. You also get the microservices capabilities with all the integration available to you for using Azure Kubernetes services with other services, not just databases, but other services like functions or Key Vault or any other Azure services. Helps you build a microservice architecture based on what your application requires. You also get secure DevOps. You can develop code faster and securely at scale. You can use dev spaces. You can use Azure pipelines. All these tools give you the capabilities that you need to have continuous integration or continuous deployment to quickly release updates to your application. Business critical applications. You can run business critical applications that require low latency, are highly performant based on the kind of applications that you're using. It could be an e-commerce application. It could be a data processing application that requires you to have better performance. You can also use Azure Kubernetes in a hybrid model. You can actually use it with Azure Arc, as I mentioned previously. You can build once and run anywhere. You can use Kubernetes and open source databases for data streaming. You can use it for real-time data collection. It helps you build various kinds of pipelines. All these scenarios are supported with Azure Kubernetes and open source databases. This allows you to build modern applications. Now let's start with a demo where we deploy a simple WordPress application in AKS with a MySQL flexible server. Let's create a simple MySQL flexible server. Public access basically allows you to connect with firewalls. So let's add the IP address of my client machine as part of the firewall rule that I want to get created when provisioning my server. Now let's create an AKS cluster called Demo Cube cluster in my resource group, my project 1. Let's use this cluster to have 4 nodes. It takes a few minutes for the command to complete, and you should see a JSON output once this is successful. While the MySQL server and the AKS cluster are being provisioned, which takes a couple of minutes, let me show you my Kubernetes manifest file. It's a simple YAML file. This YAML file helps me define what application I'm going to be running onto my cluster. Here you can see the Docker image file. This is publicly available on Docker Hub. It's basically just pulling that application, deploying onto the Kubernetes cluster. It's a simple PHP application. I'm actually deploying a custom WordPress application onto this. It's a fresh WordPress install. Now we just need to copy the database host, username, and password. Let's take this from the output of the MySQL command that I just ran. This is the MySQL server that was created. So let's copy connection string. Now let's go back to the YAML file and copy all the database information. As you can see, I've updated all my environment variables here, which point to the database hostname, username, password, and the database name. When you provision a MySQL server, you get a flexible server database created by default. And the name is flexible server DB. So I'm just using that empty database that's already pre-created. Let's go back and see if our AKS cluster has been created. As you can see, the JSON output shows that this was successfully created. Now let's connect to the cluster. In order to connect to the cluster, you need to have the kubectl tool. To do that, you just run AKS install CLI, and they should install the kubectl. Before I go ahead and start using it, I need to make sure I set the path. All right, this is done. Connect to your cluster. You need to get the credentials using AKS get credentials. You provide your cluster name and your resource group name. Now it has the credentials. It's ready to connect. Let's test to see if the connection actually worked. So let's just run a simple kubectl command to get the pods. Now let's deploy the application using the kubectl apply command, and you specify the YAML file that I showed previously. Now you can see a PHP sample app has been created. You have a PHP service created. Now let's test the application. In order to test the application, you have to make sure that the pods are actually in a running state. So let's check that. Let's check the pods. You can see the pod is in a running state. Now let's get the IP address by running kubectl get services. This is the IP address for your application. Copy it and let's run it here. Since this is a fresh WordPress install, you can see the WordPress installer popping up. Let's now provide all the information like the site name, the username, password, email, and complete the installation. Now you can see your WordPress application was created. Let's log in and now you can see the WordPress dashboard. You can go ahead and create your posts and your content and play around with the application. This demo is just to show you a simple WordPress application running on AKS and MySQL and how you would connect to it. Let's take a look at the architecture of building a really modern application using WordPress. WordPress is an open source platform written in PHP. In this example, you can see how WordPress can be built into a modern cloud native application. In the AKS cluster, there are multiple pods as you can see. One is for Varnish, one is for Redis, one is for Elasticsearch. It also creates a virtual network to deploy these agent nodes in. You can have your Azure database for MySQL in the same virtual network when you're using flexible server. Azure database for MySQL here helps store any kind of data. It could be blogs. You can also build your WordPress application to be an e-commerce store, which allows you to manage orders and catalogs. You can see that I'm also using Azure Files here, or a network attached storage. Now this system allows you to store all your media content, like it could be images, videos. The advantage of using Azure Files Premium is it reduces having to store all your images, especially if your application is media heavy. So Azure Files offers you a managed file share system in the cloud that's accessible. It gives you better performance. You can also add an Azure CDN. The CDN helps you with caching all your static content like your CSS, JavaScript, images and things like that. That gives you an additional capability of reducing the time taken to load some of these static content, especially if they don't change that often. Redis helps you store all the session data. Hosting Redis on the container itself is recommended here because you get the best performance. You can use Azure Container Registry to create your WordPress Docker images that can be easily deployed onto the AKS cluster, as there's seamless integration between Azure Container Registry and AKS. Azure Monitor allows you to collect and store various metrics and logs. This gives you the capability to stay on top of things, especially if there's something wrong with your application and you need to investigate what's going on. It also gives you all the additional metrics that you need to see if you need to scale up your AKS cluster or you need to scale up your database. Now let's do a demo of creating a simple Postgres flexible server And I'll also walk you through how you can deploy data into this PostgreSQL server using GitHub Actions. Let's create a Postgres flexible server inside a virtual network. And this will automatically create a new resource group. It'll create a new virtual network. It'll create a new subnet. It'll delegate your subnet to the server. It does all the different pieces that are needed. Now that your Postgres server has been created, you can find the connection string. Use this connection string to connect it using MySQL or any other tools that you might use. Note that this particular server is created inside a virtual network, so you must use another Azure virtual machine or an app service web app or AKS cluster to be able to connect to this particular database server. Make sure you make a note of the password. If you do forget the password, you can reset the password for your Postgres server. Now that we've created a PostgreSQL server inside a virtual network, let's try to deploy some data into the database. In today's demo, I'm going to show you how to do this using a GitHub action. Here you can see a sample repository of mine. There is an employee DB file. Basically, this file lets you create a table called employees. It also has a function which basically randomly generates 20 records within this table. Now, before we create a GitHub action workflow, let's go and check the settings to make sure we have added the appropriate information needed for a GitHub action to be able to successfully access your PostgreSQL server. Go to secrets. In secrets, make sure you create 2 secrets. One is for your Azure credentials and one is for your Azure PostgreSQL connection string. After you have updated that information, let's go back to the code and let's go create an action. Click on action. You can create a new workflow. You can see there is a bunch of sample workflows already available to you that you can use based on type of application that you're trying to build. In this case, I'm going to set up a simple workflow by myself, so I'm just going to choose this. Now, when you create a new workflow, it basically creates a new folder .github workflows and creates main.yaml file. Now in this, basically you specify all the different jobs that need to be run. In this case, log in using my Azure credentials to make sure I have access to this Azure resource. And the second thing is to make sure it has the connection string information of my PostgreSQL server. I'm also providing the server name and I'm providing the file that it needs to go import into my database. Now you can see it's creating my main.yaml file. It successfully completed the job. Let's see if it deployed the data into the tables. Now we're trying to test out to see if this particular server has the new data. You can see an employees table. Now it's going to run, select stuff from employees, and you can see that it actually created the records. Let's take a look at some of the best practices for developing using AKS and Azure open source databases. The first best practice here is, since you're running on the cloud, there could be transient errors that might occur for your application due to intermittent networking issues. So you need to implement some sort of a retry logic within your application. The second would be to use connection pooling. The third is making sure you configure the right container size for your application. Understanding your application really will help you figure out what the right container size is. And last but not the least, you need to secure your application resources for both AKS and your MySQL or your PostgreSQL databases with virtual network integration. Having all these resources within the same virtual network talking to each other gives you a secure environment. Retry logic is important if you want to have a resilient application. Now, an error can occur when you try to open a connection, or sometimes you might see some idle connections are being dropped on their server side. Sometimes you might also see that active connections that currently is executing a command is being dropped. All these different types of symptoms can occur when there are transient issues. There could be various reasons for having a transient issue. The easiest way to handle these kinds of issues is to make sure you have some sort of a retry logic as part of your application. Here's a sample code which basically tells you that it's using a retry on failure, giving a maximum retry count, giving a delay between the retries. Typically, you would want to wait 5 seconds before you try your first retry, and then you allow each retry and you increase the wait exponentially up to 60 seconds. You set a maximum number of retry counts. This allows you to make sure that It tries for 5 times and then set a maximum number of retries, at which point your application would consider that the operation has completely failed. Now, one thing to keep in mind is if your transaction was in read-only nature when the connection was dropped, then it's safe to reopen the connection and try again. But if the transaction was actually writing to the database, then you must determine if the changes were rolled back or if they were succeeded, identifying the current state of things before you reopen the connection and try again. The next best practice is using connection pooling. Now, establishing a connection to your server or to your database is an expensive operation. Now, each new connection to your server requires forking of the operating system process, new memory allocation for the connection, and as a result, transactional applications that frequently open and close connections can experience higher connection latency, which reduces the performance of your application. It's therefore recommended to use some sort of connection pooling with your application, which can significantly reduce the latency, boost the performance of your application. Now, with connection pooling, a fixed set of connections are typically established at the startup time, and it's maintained. Now, this reduces the memory fragmentation that might happen on the server as dynamic new connections are being established with the server. Now, connection pooling can be configured on the application side of things. In this case, it would be configured on your AKS cluster. You have to make sure whichever client service or client application that you're trying to use does support some sort of a connection pooling. In this example that you can see, we are using the Azure PG Bouncer. PG Bouncer is a community-based tool that allows you to do connection pooling. It's pretty lightweight. It can be installed on a virtual machine, can be installed on AKS. When the application wants to make a connection request to this database, it connects to the PG Bouncer proxy first, and then the PG Bouncer in turn tries to connect with the actual database server. You can define the maximum number of connection and the default pool size for the PG Bouncer in the configuration settings. Microsoft has published a PG Bouncer sidecar proxy image that's publicly available. Now, this PG Bouncer sidecar runs with the application container in the same pod in the AKS cluster, and it provides the connection pooling proxy to the Azure database, whether it's PostgreSQL or MySQL. If the application container fails or restarts, the sidecar container will follow, providing high availability and connection resiliency with better performance. Some containers may require large amounts of memory, hence optimizing your container size is very important. Based on your application, the number of requests and the kind of traffic that your application gets, try to identify how much memory, how much nodes that the particular application would need. If you're using Redis, then sometimes you may have to allocate 4 to 8 gigs of memory if you're using a pod for just a Redis cache. If you're running cron jobs as well that are memory heavy, that can take up quite a bit of memory as well. So you should try to architect the application in such a way that would either help you make the most of the resources that you have for your AKS cluster, or try to find a balance between optimizing the size of the container. The next demo is to scale and manage an AKS cluster as well as a flexible server. I'm going to show you how to scale your AKS cluster using an AZ AKS scale. You just need to provide the resource group and your cluster name and a node count. Let's scale it up to 6 nodes. This is a quick and easy way to scale up your AKS cluster. When you do scale down, are carefully drained to minimize any issues to your running applications. You should see a JSON output when this is successful. Let's use the AZ MySQL flexible server update command to change the storage size and compute size. I'm changing it to 512 gig as a storage and 2 vCores burstable SKU for the compute. Just like the scaling operation for AKS, you'll see a JSON output when this command completes. Now let's see how to manage your AKS cluster. You can easily start and stop your AKS cluster. Currently, this particular feature for AKS is in preview. So you need to install an extension called AKS Preview. Once the extension is successfully installed, you need to register the feature. Then you can start using the start command and the stop command. Let's stop the AKS cluster that is already running using AZ AKS stop. And now the AKS cluster has stopped successfully. Let's start it back up using AZ AKS start command. Now your cluster has started back up. The similar experience of using the start and stop commands is available for your MySQL and PostgreSQL flexible server. In order to stop the MySQL flexible server that I created for the WordPress application, let me just run AZ MySQL flexible server stop. This should stop my server. Once this command is executed, you need to start the server back up. To start it back up, just use AZ MySQL flexible server start. And this should start the server and stop features of AKS and Azure Database for MySQL and PostgreSQL. Gives you the flexibility to optimize your cost. This way you get billed for only when you're using those services. We're at the last demo, and I'm going to show you how you can diagnose any application issues, what tools is available to you through AKS and Azure Database for MySQL and PostgreSQL. Let's take a look at what's available on AKS if you want to diagnose any application issues that you might be experiencing. Let's go to the Azure portal. In the Azure portal, I'm going to my resource group called My Project One, where I created all these demo queue cluster and I created my flexible server. So you have everything available in this particular resource group. Let me go to my Kubernetes cluster. You can see Diagnose and Solve Problems page. Identify cluster related issues. This would be very important for maintaining your cluster, especially for mission critical workloads. It gives you self-diagnostic tools like Cluster Insights. It also gives you information on any networking issues. As part of this demo, let's go check out our Cluster Insights. Just click on this tile and it's running a whole bunch of checks. You can see it's running 22 checks and it gives you all the different observations. In my case, in my particular cluster, it's talking about there is some IOPS throttling that's happening, and that could be that's adding some latency to my IO. It also gives me a bunch of successful checks saying that it checked for, say, cluster management, for monitoring, logging, and didn't find any issues. So this type of a tool can be really helpful to identify if there's any issues with your cluster itself that you need to take a look at. Let's go back to networking. Let me click on networking. If I click on networking, it's giving me a whole bunch of information. You can see that it has a chat-like feature which gives you further tabs. I want to check in general, are there any network or connectivity issues? I can just choose network and connectivity issues. It runs through a whole bunch of checks. It's looking for all the outbound ports if they are set appropriately. It looked through our telemetry and logs to identify if there was any configuration issue, and it didn't identify anything at this point. There were no DNS issues as well. This would be critical to kind of make sure if you're experiencing any DNS issues or subnet configuration issues, it would be quickly identified. You can further click on search documentation and provide, say, a keyword. In this case, I'm just going to use cluster issues, and it should provide me with all the appropriate documentation links that can help me resolve the issue. Now let's go see what tools do you have in Azure Database for MySQL. Let's go back to the resource group and choose the MySQL server that was created. We're shooting our alerts for metrics. You can see all the metrics such as aborted connections, active connections, your CPU usage, your memory percent, the queries per second. The most important part on the database side is its metrics. So make sure you have configured appropriate metrics, either pin them to your dashboard or create a new alert rule. Now in this case, I'm looking at the queries metrics. It's telling me that around 400 queries were being executed from Thursday the 19th, and then it kind of dropped off. there has been no active traffic on my application here. So I can create a new rule for this particular server, and it tells me whenever the total queries is greater than a specific threshold. In this case, it should be a number, say 100 queries, and you specify how frequently it needs to evaluate. In this case, evaluating every minute. Probably I want to give it an every hour. I want this evaluation to be done every hour. That is about it. So I have it configured. Now there might be some charges for the alerts that you're configuring. In this case, it's 10 cents. Please do keep that in mind when you're trying to use some of these actions. You can select an action group where you can actually basically identify who you want to send the email to. Now specify the alert rule name, say queries greater than 100. Give a description. You save the alert to the resource group. You can also specify severity, especially if you're working with a team. And if there are multiple people who would probably get this alert, then it's good to specify the appropriate value based on how critical you think that would be for your application. Does that information give you details that your application is down and someone needs to act on it right away? So make sure you have set this value appropriately. In this case, I'm just going to choose set 3 because it's not critical. And you also configure that you enable the alert as soon as it's created. So I click on create rule. It's creating a rule, and that's about it. Click on queries to see all the metrics that can help. And on the service level, what's happening? You can see the total number of connection to see are you close to hitting your maximum connections for the server that you have selected based on the pricing tier. You can also see how much backup storage is used. CPU and memory metrics would be very important to make sure is your database server consuming a lot of CPU? Is this generated from the application side? And how do you kind of optimize your queries to make sure that your CPU usage is appropriate? Sometimes you might have to scale your server based on the activity that you see for CPU and for memory. So these are some tools that you have available for Azure MySQL. Now this alone is not the only way to diagnose issues for MySQL and PostgreSQL. If you go to diagnostic settings, you can use diagnostic settings and I get the slow query logs. You can get audit logs to get better tracking on your database, or you can choose to emit all the metrics. This configuring the diagnostic setting allows you to stream your logs to a destination of your choice. It could be an Azure storage account. It could be Azure Log Analytics, depending on which tool or which service do you want to use if you care for having a historical account of all your metrics. Now let's see how to enable high availability in a flexible server for both PostgreSQL and MySQL. Let's see how to enable high availability for Azure Database for PostgreSQL. Let's see all my resources for Azure Database for PostgreSQL and find my flexible server. Now in the overview page, try to find the high availability page. And here you can see it's as simple as just checking this box to enable high availability. Now zone redundant configuration, what it allows you to do is gives you automatic failover capability with zero data loss during unplanned events such as like underlying hardware or software faults. You will have the capability of having automatic failover. You can choose the region and availability zone to deploy as well. In this case, I have a primary and a standby availability zone. It also shows me the status of my availability. In this case, it's healthy. If there are some issues, you'll see a change in status. Some of the statuses are failing over. In this case, it tells you that the database server is in the process of failing over. If you see removing standby, in this case, the process is actually deleting the standby server. If you see replicating data, in this case, the standby is created and is actually catching up with the primary. The PostgreSQL client applications are connected to the primary server using the database server. The application read operations are served directly from the primary server, while the commits and the writes are confirmed to the application only after the data is persisted on both the primary server and the standby replica here. Due to this round trip requirement, applications can see some certain latency during write op. For other user-initiated operations such as scaling compute or scaling your storage, the changes are applied to the standby first and then it's applied to the primary server. You can also schedule Azure initiated maintenance by going to the maintenance page. This allows you to schedule or customize on when you want all the updates and patches happening on your server. If you have high availability enabled, these maintenance activities occur on the standby replica first, then it is activated. All the applications then have to reconnect to the primary server and then resume the operations when the standby is being provisioned. Now, depending on your workload on the primary server, the failover process can take longer, so do keep that in mind. If you're restarting the primary database server, it also restarts your replica. Due to synchronous replication to another availability zone, applications can see a longer write and commit latency than for the read operations. These are some things to keep in mind when you decide to use high availability feature and how it will work with your application's needs. Now let's see how to configure this for Azure Database for MySQL. Let's go back to the home page on the portal. Here are all my Azure Database for MySQL servers. Let me find a flexible server. One of the requirements for Azure Database for MySQL server, if you want to use high availability, is that you can currently only enable high availability when you're provisioning the server the first time. So click on Add, choose Flexible Server, provide your information. For this case, I'm going to choose a production small medium size workload. This will enable a general purpose pricing tier with 2 vCores and 50 gigs of storage with 8 gigs of memory. Now I can enable high availability. I have provided a username and password. Let's go to the networking page. You can choose private or public access here. In this case, I'm just going to use public access. I'm creating a firewall rule for my machine. And now I'm going to create my MySQL server. In review and create, look at the estimated pricing for your server, check all the values that you have configured, and finally click on create. You will see a deployment page open up and it'll tell you that your deployment is in progress. It also gives you further information and a correlation ID for this particular deployment. This is useful for us to figure out what type of issues you might have seen during your create to investigate further. It can take a few minutes to complete. As you can see, now my server with high availability feature is deployed successfully. Let's go to the flexible server. Here you can see the high availability page, and you can see that zone redundant HA is available for you. In terms of the capabilities, it is similar to what I described for PostgreSQL. So you need to keep all those limitations and capabilities in mind when you decide to use high availability for MySQL. Remember that there are different states in which your high availability primary and standby servers will be in. whether it's healthy state or failing over state, or in removing standby or replicating data state. You will not have the ability to remove your standby replica by disabling high availability related. Will be performed on the primary database, and it will be stored in a zone redundant storage for you. If there's a failover event, your new standby is provisioned in the original primary availability zone. So these are things that you still need to keep in mind as you decide to use this feature. Now let's take a look at the next demo, which is enabling high availability on Azure Kubernetes services. You can use high availability with AKS by creating an AKS cluster in an availability zone. So let's click on Kubernetes services. Now let's create a new one. Now here you can see that for region South Central US, there's no availability zones. So all the availability zones are dependent on the region that you use to deploy your cluster. So certain regions will not have availability zones, and hence you won't be able to use the feature at that time. Let's change this to East US. Now you can see I have availability zones listed here. Now I can choose and modify my availability zones based on how many do I want. In this case, I'm just going to use the default as 1, 2, 3. What this means is there is a total number of 3 nodes that will be created for your AKS cluster. One agent will be in zone 1, one will be in zone 2, and one will be in zone 3. So if you decide to use fewer zones, you can uncheck one of these zones. Now let's go ahead and create this particular AKS cluster using 3 availability zones in East US. Provide the cluster name, make sure you've chosen the size. Now the availability zone is also dependent on the size that you're using, of size of VM that you're using for your cluster. Certain virtual machine sizes, it's recommended not to use zone redundancy with. So let's check the pools. Now I have one agent pool, it's using Linux, I have 3 node counts, and I have my virtual machine size here set as DS2v2. You can add additional node pools if you need. You can enable virtual nodes. You can use virtual machine scale sets is enabled by default when you're using availability zones. This gives you the ability to scale. Now let's configure the authentication method for the cluster, networking, and the integrations with Azure Container Registry if you need, or Azure Monitor. Let's click on Review and Create. Now let's verify all the properties that we have enabled here before we click on Create. Let's create the cluster. Now your AKS cluster has been deployed. You can go to the resource. Let's go to the node pools page. Here you can see the node pool that was configured for you in this cluster, and you can see the availability zones listed out. This is the most easiest way to configure an AKS cluster with high availability and providing which availability zones you want to use. You can also do the same configuration of high availability feature, whether it is for Azure PostgreSQL Flexible Server or Azure MySQL Flexible Server or AKS, using the CLI experiences that I showed in some of the previous demos. We created a cluster with 3 availability zones. The AKS service manages the distribution of the node pools across these zones. To verify the node distribution, you can use kubectl describe command. This will list out the nodes in the cluster, and the output here shows you that each node has been distributed across the zones in East US, since that's where we created this cluster. If you scale up from 3 nodes to say 5 nodes and run the kubectl describe command again, you should be able to see how these nodes are distributed. Now let's take a look at the limitation of these services. Now let's take a look at the limitations of Azure Kubernetes services. Now zone availability, as I mentioned before, is only available based on the regions that you choose. So do check out the regions before you decide to enable zone redundancy for high availability. Now each service and resource has a certain set of quota limitations that you need to keep in mind. For AKS, we can have 100 maximum clusters per subscription. You can have 100 maximum nodes per cluster. This depends if you basic load balancer SKU. If you're using the standard load balancer SKU, you actually can do 1,000 maximum nodes per cluster. Also, depending on the networking, whether you're using basic or advanced networking, the maximum number of pods supported varies. Now, each node in the cluster, it contains a fixed amount of compute resources. So there are certain virtual machine SKUs. Now let's learn about the limitations of Azure Database for MySQL Flexible Server. Now, MySQL Flexible Server supports tuning the values of your server parameters, but it limits or has restrictions on some of these parameters because it's a platform as a service. The minimum and maximum value of some of the parameters, like say maximum connections, join buffer size, query cache size, this is determined by the compute tier, depending on whether you have burstable or general purpose or memory optimized. Also note that some of the password plugins, such as validate password and the SHA-2 password caching, is not supported by the service. It also only supports InnoDB and memory engines. MySQL service does not allow direct access to the file system as well. It also prevents you from certain data manipulation commands. The connectivity method cannot be changed once the server is created. So if you have created with the public access, you cannot change it to private access, and vice versa. It uses TLS 1.2, so make sure your client-side application is also using TLS 1.2. SSL is enabled by default and it cannot be disabled. So make sure your application is connecting to the server using SSL. The start and stop features are not supported when you're using zone redundant high availability configurations. Same goes for read replica. If you have created a server with say storage of say 10 gig, you cannot decrease it to 5 gig after provisioning the server. So keep that in mind when provisioning the storage. The migration from one version to another version is currently not supported on Flexible Server. In order to do a major upgrade version, you need to do a dump and a restore to the server, dump and restore to a new server created with the appropriate engine version that you need. The backups are always snapshot based, they're not differential. So as we keep taking snapshots of all the backups for your database, or you may have multiple databases, this would increase the storage utilization for your server. So keep that in mind in order to figure out how many databases you want within your server. Now let's take a look at the PostgreSQL Flexible Server limitations. Similar to Azure Database for MySQL, there are certain limitations in terms of what server parameters can be modified here. The maximum connections is determined by the compute tier and the compute size of the server, just like the MySQL Flexible Server. Connectivity method cannot be changed after creating the server, so make sure you are choosing the right method at the beginning itself. You cannot move from private access to public access or vice versa. If you're using a client-side application, make sure it's using TLS 1.2. And it should also connect to the PostgreSQL server with SSL. The start and stop features again are not supported when you're using zone redundant HA configurations here. The read replica feature is also not supported. Decreasing your server storage is also not supported. Doing in-place version migration, just like the MySQL Flexible Server, it's not supported on PostgreSQL. You would have to do a dump and restore of your server and move it to a new server that you created with the right version that you need. Postgres 10 and older versions are not supported, so if you need the server using an older version, try out our single server option. Extension support is currently limited only to the Postgres contrib extension. But we do plan to add support for other extensions in the upcoming months. Changing the maintenance window less than 5 days before a planned upgrade will not take into effect. So if you see that there has been no changes taken in effect, then this could be the reason why. Changes will take into effect only on the next scheduled maintenance and follow the new schedule that you have configured. Backups again here are always snapshot based, so make sure you're using enough storage and taking into account how many databases are there on that server. to identify how much storage you would need for all the backups. The more number of databases you have, it could cause issues with exhausting your storage resource for your server, since the backups also need some storage space on the server. That's all we have for today. Thank you for joining and taking the time to attend this session. Before we go for questions, these are some important resources that would be useful to you. You can reach out to the product team with the emails provided with Ask Azure DB for MySQL for the MySQL team, and Ask Azure DB for PostgreSQL for the